In this video lecture, we'll see about the Class A power amplifier. Class A power amplifier is one in which the output current flows for the entire cycle of the AC input supply. Hence, the complete signal present at the input is amplified at the output. From this figure, we can observe that the transformer is present at the collector as a load. The use of transformer permits the impedance matching, resulting in the transference of maximum power to the load, that is loudspeaker. The operating point of this amplifier is present in the linear region. It is so selected that the current flows from the entire AC input cycle. So the below figure will explain the selection of the Q point, which is essential. The output characteristics with operating Q point is shown in the figure. Here we have IC and VCE at Q point represents no signal collector current and voltage between collector and emitter respectively. When signal is applied, the Q point shifts to Q1 and Q2. So the output current increases to IC max and decreases to IC minimum. Similarly, the collector emitter voltage increases to VC max and decreases to VC minimum. So this is the overall efficiency of the amplifier circuit, which is, of course, we have seen in the previous lecture, which is P naught AZ to the P in DC, that is output power that is delivered to the load and to the ratio of the total power delivered by the DC supply. Similarly, we can write the efficiency for the collector, which is average AC power output by the average DC power input to the transistor. So the expression for overall efficiency is given over here, so which is Vrms into Irms, which is equal to the power output, that is your AC power output. So the expression, you can see it in the slide. So these are the important expressions that we should remember, that is IBQ, ICQ, VEQ, Q point, then PAC, then what would be the efficiency percentage and power dissipation. So what are the advantages of Class A amplifier? So the current flows for complete input cycle. It can amplify small signals. The output is same as input. No distortion is present. However, it has certain disadvantages. So low power output, lower collector efficiency. So this is actually the transformer coupled Class A power amplifier. So as we have seen in the previous explanation itself, there will be a transformer at the collector side or in the collector load. Here R1 and R2 will provide a potential divider arrangement. So you can see certain resistors RE which will provide stabilization, CE which is a bypass capacitor, and this will prevent the AC voltage. So the transformer used here is a step down transformer. So the high impedance primary of the transformer is connected to the high impedance collector circuit. So low impedance secondary is connected to the load. That is, generally we connect a loudspeaker, say for example. So the transformer used in this collector circuit is for impedance matching. So you can see the detailed transformer circuit plotted down, where you can see RL is the load connected in the secondary of a transformer. RL dash is a reflected load in the primary of the transformer. So the number of turns in the primary and the secondary are N1 and N2 respectively. And similarly, the voltages and the current will be like for the primary and secondary, it will be V1 and V2 and I1 and I2 respectively. So these are the parameters where we could derive or we could calculate. So we know that V1 by V2 will be equal to N1 by N2, and similarly I1 by I2 is equal to N1 by N2. So from this we can derive what is V1, what is I1, and the ratio of this V1 and I1 will tell you what will be the effective input resistance and output resistance. So from this we could be able to derive what will be the RL dash, that is a reflected resistance, in terms of the turns and the load resistance. And of course the N is nothing but, here I have mentioned a N over here, which is the ratio of number of turns in primary to the secondary. So we need to match the power amplifier by taking proper turn ratio in step down transformer. So circuit operation, if a peak voltage value of the collector current due to signal is equal to 0 signal collector current, then the maximum AC power output is obtained. So in order to achieve complete amplification, the operating point should lie at the center of the load line. So the operating point, it varies when the signal is applied. The collector voltage varies in opposite phase to the collector current. So the variation of this collector voltage appears across the primary of the transformer. So this is how the circuit is analyzed, where the power loss in the primary is assumed to be negligible as its resistance is very small. The input power under DC condition will be given by the above expression. Okay, and the efficiency of class A amplifier is nearly 30%, whereas it has got to improve to 50% by using a transformer coupled class A amplifier. So if I am going to use a very normal class A power amplifier, then it will be only around 30%. So the advantages of using a transformer coupled class A power amplifier are as follows. That is, no loss of signal power in the base or collector resistors, gain is high, excellent impedance matching, DC isolation is provided. But still it has certain disadvantages. Low frequency signals are less amplified comparatively. Hum noise is introduced by transformer. Transformers are bulky and costly. Poor frequency response.